time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too late. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard to follow before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another epic day here in 100 days of Rootkit. Yesterday, we finished up showing the usefulness of SQL, integrating it into our game. Today, we're going to finish up that integration and go straight to another game, our dungeon crawler game, and show how to integrate it in a larger game, more sophisticated tables, hopefully a closer to real world example. All right, we're just continuing our database journey. All right, continuing our database journey. I hope y'all are excited because I know I am. All right, and we're gonna go kill it today. Good old coffee. Alrighty, before we do that though, let's go ahead and finish up with our intro here. If you don't know, we are Rootkit, a nonprofit organization based here in the US of A. Don't go to college. Don't go to any other boot camp. Come to us. Get our cert. It's the best in the industry for a reason. Alright? Come get certified for us and we will get you a job. Alright? On top of all this free goodness we're doing, if you go over to our blog section here, you can see the week 11 giveaway is up and live. So make sure you enter that to win some free merch, all right? All you have to do is press this big green button, show that you're subscribed to our YouTube channel, follow us on Twitch, and bam, now you have points on here that you can then collect and be entered to win, all right? We're going to pull that on Sunday. If you like what we're doing and you want to help support us, because doing things for free is a little expensive, all right? It's a little expensive. Then, bambo, you can donate to us. All donations are matched 1-for-1 for the first 10,000 donations. And when you donate, depending on how much you do, you can unlock certain rewards, like our epic stickers, our super cool collab t-shirt, and our exclusive 100-day of Rootkit sweater. I know, super epic. And again, remember, they're all matched 1-for-1 and tax deductible because we're a charity. So don't let Uncle Sam take all your dollar bills. All right, just donate them instead. We have pillars along the way, like streaming for 24 hours straight, shaving my head here live on stream, and the goal we don't want to get to. All right, our goal is not to hit that goal. Shaving my beard here live on stream. No one wants to see that, so we don't need to worry about it. All right. Alrighty, oh, that was hot, and then I spilt all over myself. Let us continue our journey. Before we do, are there any questions? I didn't see anyone ask any questions yesterday in the 100 Days of Rootkit chat. I'm looking at the Twitch and the YouTube chat right now. Any questions before we continue our journey here? And I guess I should pull up DBeaver. DBeaver. This thing takes forever to load up. Alright, so while it's loading, and I don't see any questions, so go and ask if you do have questions though. We finished up yesterday showing how you can make startup scripts that will auto do a task for you, like maybe create the database, maybe put some data in there initially. Maybe you don't want to put any data in there initially. That's fine. You can still have scripts that run on startup for doing some type of logic to prep, make sure everything is a-okay. All right. Additionally, on our application here, we added a couple new lines of code and removed a bunch, all right? We're no longer reading from a file. We're now connecting the database and randomly getting a word from the database, all right? Randomly getting a word from the database and using that in our game. The last thing we want to do here is now save the score. Save the scores off. So we should make a startup script to go along with this so we can auto create that database for holding all the scores. So let's go ahead and do that here real quick. So in our startup folder, we can go ahead and make a new file and call this creating high score table.py. All right, and we have the SQL code we need right here. All right, we have the SQL code we need right here. We just need to connect to the database, run that code, and bam, it has been created. It's just that simple. We already have that code right here. So let's go ahead and copy and paste. Our favorite friend. Copy and paste. Copy and paste. We don't need the try and accept. Right? We don't, or I guess we can still use the try and accept to let us know whether an error has happened or whether it was just a duplication table, which means everything was good. Everything's already created. And the last thing we need here is a con.close, because we want to make sure we're closing the connection nicely. It will close automatically if you don't include it, which we haven't included in a couple of these scripts, which is just fine. But to make things nicer, better, and more efficient, we want to close it, all right? We want to close it. We want to be responsible. When we open something, we also close it. All right, any questions so far of what I've done? We just copy and pasted some code over from that other script and then added the close line at the very end. We haven't done anything else besides copying and pasting, and I guess making this file in the startup folder. All right, the next thing we want to do is change these SQL statements here. All right, change these SQL statements so they are the ones that we need to create this table, which we stored off in this file right here. These are the SQL statements. There's 3 of them in here that we need. And I'm pretty sure we can do all 3 of them together in one execute, because again, remember these SQL statements are separated by semicolons. So you can have multiple of them in the same execute. So if we do this, this should work. All right, this should work. We'll see here in a second because we'll test it and see. All right, if this is successful, then we just want to print out that it was successful. So we don't need this connection rollback anymore because we're not doing anything afterwards. And we can say everything went well. Actually, we could just have it here at the end, because if it throws this exception, everything went well. If it didn't throw the exception, then everything still went well. So instead, what we would do right here is just a pass. So if this exception happens, that's fine. Just move on, ignore it. All right. If any other exception happens, then tell us. And whether this exception happened or it didn't happen, everything went well. All right, went well and created the table. It will always tell us everything went well. All right. So if we run this right now, so let's cd into the word guessing and then cd into startup and do Python creating high score table. It says everything went well. If we look at our database right now, and let's go ahead and open this up, we already had the table created, which means everything went well. Most likely it threw that error, that duplication table error, but it handled it by just doing nothing. All right, it handled it by just doing nothing, being like, okay, this error happened, whatever, let's move on. All right, and it just prints this statement. We can also test and see if this actually works and creates the table by deleting the currently existing table. So we open up this, go to the high score table here. Let's go ahead and delete this. All right, so now it's completely gone. Let's rerun our script and look at that. It worked, which confirms several things for us. 1, that this script worked. 2, that we were correct in our assumption of the semicolons and having multiple SQL statements in once in an execute statement. All right, so this is completely valid for you to do. All right, there's 3 of them in here. Let me space it out a little bit so you can see those are the 3 unique ones. And if we look at the database, remember it won't show up here by default. We have to refresh everything. So if you go to the very top level and we right click and then click on refresh, or you can press F5, I guess there's a shortcut right here, we can see the high score table now shows up in here again. So everything was created successfully. And if we click on it, we can see that all of our columns are in here. So that's super epic. That's super awesome. And it was super easy to do. It's always like the first little code that you have to write that's always the most time consuming. Everything after that is pretty much copy and paste and super easy. As you can see, we created this script in like 2 seconds. All right, it was super quick, super easy, and we got all that powerful functionality. Any questions on this before we continue forward? Before we chug along here. Let me pull up the... And again, if you are a Patreon or Discord premium member, I am in the events chat. So you can go ahead and hop in there at any time, and you can just vocally chat with me, talk, ask questions as you see fit, all right? Alrighty, I don't see any other questions, so let us chug along here. And I just realized that we're missing the event on Discord, so let me go ahead and start this event real quick. There we go. Create, and let's go ahead and start. Alright, so now that we've created this, next thing we want to do is git commit. All right, we want to save this progress that we just made. So let's do a git add all, and then we'll do a git commit, and then we'll go and put in here that we created the file for. So this is creating the high score table, created for auto setup of base high score table. All right. Let's go ahead and git push this up. And we've done that. So everything's nice and saved, pushed up, officially done, and we're good. We can now share it with all of our buddies that are on the same repo. All right, on the same repo as us. Now the last step we have is in our code here, replacing this where we're saving all the scores to a file, and instead having it so it goes to the database, right? Having it so it goes to the database instead. Now, just like everything, there's a bunch of ways you can go about tackling this, all right? There's a bunch of ways you can go about tackling it. So right here at the very top of our game, right? At the, wait a second, this isn't the game, hold on. Here we go. Sorry, that was kind of confusing. All right, right here at the very top of our game, right? At the very top of our game here, we connect to the database, we do something, and then we close it, all right? We could, if we want, not close the connection. We could keep it completely open, so that way we can use the cursor down here later on, and then update the database, That would 100% work, and then we can close it at the very end of our program, right? Will 100% work, right? There's nothing really too wrong about that. I personally won't do that, and I'll show you guys here how I would go about doing it for a couple reasons. One, this is a game, and you don't know when they may lose. This game may be open for a very long time, so you're keeping this connection open to the database for quite some time potentially, which is not too much of a load, but it is loading, adding a load to the database. All right, it has to maintain this connection, and maybe it doesn't do auto maintenance of that connection behind the scenes, because by default connections have to expire eventually. Sometimes, I guess it depends on how it's set up, but that's the thing right now, is we currently don't know how this is set up. So we don't know if there's a timeout built in the sense that after maybe 5 minutes it automatically closes the connection, or maybe it automatically closes the connection and then it re-establishes the connection when we do a new execute. We don't really know exactly how it's handling the connection behind the scenes. All right, so you can go look into that, or what we can do is assume and know what we do know, which is that keeping a connection open for a game that we never know when it may or may not end is bad. Additionally, there's nothing from stopping the player from closing this game abruptly at any time, or assuring Command C and basically severing this game in half without us properly closing it if the close was at the end, all right? Which would not be as proper either, all right? So I would personally keep things like they are here, where we open the connection, we do whatever we want to do, and then we close it, all right? Open, in, do whatever we need to do, close it, we're out, all right? And then we'll reestablish, reconnect to the database later on when we need to go back in and establish a connection, all right? That's what I would personally go about doing. Now, you don't have to do it this way. Again, it's totally up to you. Both ways are completely valid. The only thing is I would say look into these statements a little bit more, figure out how it goes about connecting, reconnecting, maybe do some testing behind the scenes. I would assume it will automatically reconnect for you, but that's how we're going to do it here. All right, mostly so we can get more practice with writing all these commands on top of everything. So if we copy all of this code and then repaste it down below, we will have everything good, or have this whole setup down below. But now you're getting into not so dry code anymore, because we're going to have another connect, another cursor generation, and then potentially another close. So mostly the big bad thing here is the connect. Because now what if the database name changes, or the username, or the password changes? Now we have to go to multiple places in our code and update this information. It's not ideal. It's not ideal. Now, yeah, you can easily copy and paste this, get things running, and then change it after the fact. That is a-okay. But we're going to go ahead and set this up a little bit nicer, all right? Before we continue on here, So what we're going to do instead is put this all into a function like DB connect. I don't know, I'm calling it DB connect. So this is going to be for connecting the database, and it's going to be returning to us the database connection, which is going to be a connection object, which hopefully just synapse2.connection. Here we go. There we go. So that's what it's going to be returning to us. And all we're going to do is take this code, paste it in here, and instead of equal to connection, we're just going to have it return that variable. All right. So it's going to connect. Connect here is going to return to us that connection variable, and we're just going to return that back forward. So now instead we can just run DB connect like this, and then we'll get our connection. Yes, it's still kind of wet. All right, the code's not as dry as possible, but it is a little bit more dry. All right, it is a little bit more dry. The most important thing here for the dryness is now we don't have to go around changing the database name, the username, the password in multiple like locations. All right, and sometimes things will be a little wet. All right. That is okay. It's, again, these are general rules of thumb, rule of thumbs, right? Hopefully I got that saying right. I don't know, it just sounds weird to me right now. But these are just general rules that you can follow. They aren't applicable 100% of the time, because again, it just always depends. It always depends. So it's best to stick to it, but no, it's okay if things are not as like just straight up bone dry. So what I mean by that is we still need to connect to the database, and we still need to generate a cursor, and we still need to close. So each one of these statements, all three of these, are going to be duplicated here at the bottom. All right. So we're going to have a connection because we have to connect to the database. We have to have a cursor because that's how we talk to the database. And when we're done with stuff, we need to close that connection. All right. There's not really any other way around it. You have to do it. So it's okay. It's okay. So now we here at the bottom are connecting the database, getting our cursor, and we're closing. So inside of here is where we need to do our logic of where we're saving the information of the user. So this is going to be replacing the file write operation. So I'm guessing we should actually put our code right here because it will be replacing these 3 lines of code. So let's go ahead and copy these and actually move them down right here. And we no longer need to open the file, which it was going to the save file, which we can now delete. We no longer need to close the file, and it looks like we have a variable called name and a variable current score. So that's good to know because we can use that in our SQL statement here. The next thing we know is when we want to run a SQL statement, we have to do cursor.execute and put it in here. Additionally, once we're done with that, we have to do the commit. So let's do a connection.commit right here. So we have our base layout completely done. right? Our base layout completely done for this logic. We just need to enter our SQL statement. We already have the variables with the items in it, right? Name and high score, or current score current, my bad. We just need the SQL statement. So this would be our insert statement, right? Insert statement. So let's go ahead and get triple quotes going here. And so this is where we would want to insert. So insert into, remember it's insert into, then what table? We want to enter it into the public dot high score table, all right? And then next we need to say what columns we're entering data into. And these I don't remember off the top of my head, so we can refer to the database. We have name, score, and timestamp, all right? Name, score, and timestamp that we want to enter into. And we're going to put in the, I think it's values plural. Let's see here if we refer to our other script here, values plural, right? Values plural, perfect. And now we can do %s for the name, %s for the score, and then we need %s for some type of timestamp that we will need to generate, right? That we will need to generate. All right, this looks good. So then we'll put a comma at the end, and now we need to feed an array of those values of the name, the score, and the timestamp. So the name, the score current, and then some type of time value, right? Some type of time value. We'll have to figure out the time value here in a second. Are there any questions before we continue on? The reason why I wrote out this one this time is so you guys understand you got to start memorizing these SQL terminologies. Now, I don't expect you to master them overnight, all right? But try to challenge yourself, all right? If you know you need an insert statement, see how far you can get before you have to refer to something else, all right? Refer to the database and see the auto-generated code it makes, or maybe refer to code that you've already wrote earlier, all right? See how far you can get before you have to do that. And just keep testing yourself, right? Just keep testing yourself. It's the only way to keep getting better and better. Any questions on that before we continue? See here. All right. I don't see any questions. If you do have any questions, make sure you ask. So we can run this right now, and it will work kind of. I'm pretty sure we can't give it an empty timestamp. But also, what is a timestamp? What is the format of a timestamp? We can always do testing in the database. So remember that. Use the GUI constantly to test and see what works and what doesn't work. So let's go ahead and mess around with this statement a little bit. Let me go ahead and do some zoomies here so you guys can see it a little bit better as we continue on. Hopefully that's a little bit more clear for you guys. So we got our statement right here. Insert into public high scores, name, score, timestamp. Now we got to replace these. So the name, we can just put in a name here. The score, let's give ourselves a really good score. All right. We need to look good, right, on the high scoreboard. And next is a timestamp. Well, we don't know really what to put in there right now. So let's see if it will actually take, what do you call it? Just two, or an empty string, right? Let's execute. And it looks like it doesn't really like that. Zero length delimiter identified at or near this position. I wonder if that's actually a different error. No, it's highlighted the underscore area. So it doesn't really like that. It doesn't really like that. So let us see here. This is where again, you can do some experimentation. So we know that will not work. Additionally, we could try and do no value. So let's try to insert something without the timestamp, and we can see that doesn't work either, right? Column Elijah does not exist. So that means we do need that timestamp column, right? We do need that timestamp column. So the last thing we would want to potentially do is go do some Googling. Go do some Googling. So if we load up our web browser here, let me make it the same size of the resized screen here. All right. So we would want to do some Googling here, and when we Google here, we can go ahead and Postgres timestamp, right? This will bring us to the documentation. Hopefully that's going to be link number 1 for you. So whatever database you're on, you're trying to get to the documentation for that database so you can see what exactly a timestamp is. Because it might make sense, like a timestamp should be a timestamp, right? But what's the format of it? Does month go first? Is there even month in it? Is it just time? Is it epoch time? Is it not epoch time? Is it a string? Is it an integer? We don't know. We absolutely don't know unless you take a look and view what the documentation says and then potentially memorize it. So we have date/time types. So timestamp without time zone is going to be 8 bytes in size. It has both a date and a time. And it allows us to go back to 4700 BC all the way to 294,000 AD. So quite far in the future, right? Quite far in the future. So this may be different than what you might have thought originally, which may be time, which is literally just the time, or date, which is just the date. Timestamp is both the date and the time, right? And you have the option of using without a time zone and with a time zone. Now the question is, how do we even give it that information? How do we even give it that information? So let's go ahead and look further down the docs here. We have some explanation here about stuff. Alrighty, date input. So these are ways to import or input the dates. All right, input the dates. Looks like there's lots of different ways to input the dates. And here's for time. Lots of different ways to input the time. And then time zone. Here are some ways to import the time zone. And then here are time stamps, which we're doing. We're doing those. So these would be valid ways to add timestamps. All right, seems simple enough, right? So let's go super simple without a time zone. And it looks like this may be some type of string value. All right, some type of string value because there's all this text. This isn't a whole number. There's a bunch of stuff here and things that aren't numbers, like these dashes. So it must be a string. So let's load up the database here and paste this information. Even though this is not the current date, let's just paste it in, run it, see if it even works in the first place. All right, so let's try to run this, and we're getting an error. So there might be something wrong with our SQL statement. Next, so let's go ahead and do a quick sanity check here. So name, score, timestamp. Name, score, timestamp. Let's go ahead here. Name, score, timestamp. Public.highscore. This is all looking correct so far. So maybe we want to auto-generate an insert statement. Copy that and paste it in here to see what's different. And I guess we need some quotes. I don't know why. All right, I don't know why, but it wants us to have quotes around name and timestamp. I mean, my assumption is these aren't integer values, so that's why it wants quotes, but it seems like a silly reason to me. And then we have values and the 3 values. So that looks good. Let's go ahead and try to rerun this. And we're getting another issue. Oh, it doesn't like double quotes. I forgot. Let's change these to single quotes. All right. Sorry, I forgot it does not like double quotes. So let's change these strings to single quotes. All right, and let's rerun. And that worked. Let me rerun this without the double quotes around name and timestamp here. That should work too, I believe. Let's rerun this. That worked too. Okay, so you don't need the quotes around this. But the issue was we had those double quotes. We just need to change it to single quotes. So now if we look in the high score database and look at the data tab here, you can see, looky looky, we have some high scores. We have some high scores. So that is pretty neat. And now that we also know that this is working, let's try this again with no data. With no data in it, see if that works. And that still gives us an error. So it still wants us to have the correct data. I guess the last thing to try is not doing the timestamp at all. So let's not even give it, or say that we're going to give it timestamp data. And that still fails also. There is a way to auto do data for your fields, but we're not going to show that off right now. All right. So basically it would automatically put, just like how our IDs are auto incrementing, we can have it so it automatically puts a timestamp into the timestamp field when we create this record. All right. When we create this record. Any questions so far? I'm going to rerun this to show. Why are you mad at me? What'd I do this time? Oh, now it's working. Never mind. It's not mad at me anymore. Any questions in regards to this? Before we continue onward with our journey here. I'll wait a couple more minutes here for any questions. Or not a couple more minutes, a couple more seconds. All right. So, since there are no questions, we'll go ahead and continue forward. The next question we need to ask is, how do we get this date in Python? How do we generate this? Great question. Seems like something you go to Google for. That's right. Or if you're using an assistant, ask your assistant. All right. Ask your digital assistant, how can you get this in Python? All right. So let's go ahead and go in here or to the Googles. And we already have a Google's open right here. So let's say Python generate timestamp, right? Because that's what we want, right? We want a timestamp. So it looks like there's an article here for generating timestamps. This doesn't look like it will work. So doing this thing called time.time and printing that out generates this. That doesn't look like it would work. So let's go ahead and look further here. This looks more like what we're looking for, all right? This current time right here, which we can do by doing importing date time and doing datetime.datetime.now, it looks like, all right? datetime.datetime.now. So let's go ahead and try that out, right? We could use a test script like we did earlier, or we could also just open up PowerShell and bring the, what do you call it? The, whoops, what did I just shrink? No, I just did I mess up the, I think I messed up the top, our top goal bar. I have no clue where that is. Let me go ahead and resize the screen so it's back to full size here. So that's snapped. There we go. All right, I think we're good now. All right, we good? So let us continue on. All right, that's not what I want to add. All right, sorry guys, give me like 2 seconds. It's gonna annoy me if this doesn't. It says it's right here. Why is it not showing? Oh. All right, Just like magic, it has showed back up. All right, let's continue on. So what I personally would do would be pulling up the Python interpreter. So if you pull up your PowerShell, or if you're on Mac OS, your terminal, and we type in Python, or if you're on Linux or Mac OS, Python 3, we can get the interpreter here. The interpreter allows us to write Python code and quickly test stuff. So according to this article here, so let's put that here, we need to type in import date time. All right, and then we can do date time dot date time dot now and see what it outputs. This doesn't look correct in the sense that it wouldn't work well for us, but maybe it needs to be made into a string, right? Maybe it needs to be made into a string. So if we cast it into a string, date time dot now. Ooh, that looks good. That looks like that might work for us. Now you might notice there's this decimal point that tells us the milliseconds and nanoseconds or whatever other seconds there are here. So to test if this will work, we can go ahead and copy it, go to our database viewer, and then paste it in here and just try it out. Just try it out. So let's go ahead and execute it. Looks like it worked. Let's go ahead and view the high scores table here and refresh. And it looks like it took it. It looks like it took it. So it looks like it will handle all of these precise values just fine. So that's how we can go again. Again, this is how we can go about discovering new Python features and functions that we can use to enhance everything. And it's done auto-magically for us, so we can just use it right away. So now all we have to do to get this last value is go up to the top, import date time, all right? And then in here, instead of a blank string, we want to cast to a string the date time dot now. So this will give us the current live date, immediately. The second this is ran, it's whatever the most up-to-date, like this current time is. So we will know that we're always getting the latest and the greatest. We don't have to do any weird, confusing logic ourselves to calculate what date it is and then enter it. It's just done auto-magically for us. And that is exactly how you go about adding full database integration. Now everything is pulled from the word list in the database, and we're saving all of the records to the database for high scores. So let's see this in action. Before we run our program, I'm going to go ahead and delete all the records in the database here. So we have a completely clean database, so there's nothing in the database here. So when we run our game and get our high score, it should be the only record that shows up in here. So if we go ahead and load up our game, so we'll say this is in the startup folder, so let's leave that folder and do Python word guessing. No module connection. Did you mean connect? So it doesn't like this connection thing here. This is a class. Would connect work? I don't know why connect would work. That doesn't make any sense. Oh, it does. All right. I ain't gonna question it. All right, I ain't gonna question it. Let us continue. Does that actually? Hold on. Con dot. Yeah, I don't. Hold on. Hold on one second. That doesn't make. This is supposed to return a connection. Where's the connection value? I guess we could do the shift or the control click to see here. This just says any, so it doesn't even specify. Okay, I'm gonna ignore. This is gonna annoy me though. Now this one says any. Are you kidding me? Okay, we're just gonna go ahead and just say nothing for now. All right, we're just going to say nothing for now. All right, let us continue on here. So our game has started successfully. We have a 3-letter word. How convenient for us. All right, I think I could win this one. We have a score of 0, 2 attempts left. So is this car? Let's do an A. Maybe it's R. Let's do an R next. Holy crap. Those did not go in the locations I expected at all. Is it air? Let's do an I. We won. We won. So let's go ahead and put our name in here. Billy Bob. And Billy Bob was bad input. All right. So we have input protection because I'm guessing it wants just one, a one-word name. All right. One-word name. Yeah, that's all just alphabetical. So let's go ahead and just do Billy. And there we go. It looks like it worked successfully because we didn't get any error message. So let's go to the database and refresh. And what do you know? We have Billy with his score and a timestamp in there. That is super cool. That is super awesome. Now we can use this database to do lots of fun information with the high score stuff. We can add high score boards that are shared globally throughout the world, or and just maybe in the state, or whoever your users are now can have access to this everywhere because it's no longer just in a file locally on their machine. You can connect out to a database anywhere around the world and enter this information at any time, which is super cool and super awesome. All right. That's the super cool powers of databases. Any questions on this before we chug forward? Anything that you guys need clarification on, right? Anything you guys need clarification on, please ask. Please ask. With Dungeon Crawlers, we are going to start from scratch again. We're going to do our database design, think about it, think about what tables we need, look over everything, and then we'll generate more startup scripts for auto creating the tables, all right, if we ever need to run them again. So we don't have to do it by hand. And then we're going to start integrating, right? Start integrating. Any questions before we move onward? All right, if not, maybe we'll take a little bit earlier of a break since this is a nice natural breaking point before we move on to our dungeon crawler. I guess before we go on a break, let's go ahead and get, add, and commit all of this, and then we'll take our break for 3 to 5 minutes. Please ask any questions you guys have, and then we'll continue with this journey over in the dungeon crawler. So let's go ahead and do and get add all and get commit, and then we can say we added what do you call it? Score saving to the DB, and then we'll get push that up, and bam, we are good to go. We are good to go. So we're gonna go on break for 3 to 5 minutes. If you have any questions, please ask them. All right, please ask them in the chat, and I'll answer them when we get back to it. So I'll see you guys in 3 to 5 minutes. Alrighty. We are back. Let us continue our journey here. But before we do, let's go ahead and redo, our intro here real quick. If you don't know, we are Rootkit, a nonprofit organization here in the US of A. Don't go to college. Don't go to any other boot camp. Just come here. You're already here right now. You're watching. And get certified. We're the industry's best comp sci cert for a reason. Get certified, get a job. All right, it's really that simple, right? It's really that simple. On top of all this free stuff we're giving you guys, if you go over to our blog, we have our week 11 giveaway up live now. All you have to do is press that green button. Once you do, just show that you're subscribed to our YouTube channel, following us on Twitch, etc., and you'll gain more entries. You'll gain more entries for the giveaway coming up this Sunday. All right, coming up this Sunday. So make sure you enter. If you like what we're doing and you want to help support us, doing stuff for free is kind of expensive. All right, kind of expensive. So you can donate. There's a link in the description of this video, and then if you're on Twitch, it's somewhere there. All right, you can find it. But when you donate, you can unlock certain rewards like our epic stickers, our collab t-shirt, and our epic sweater. Remember, we are a charity, so look, you get to avoid taxes and donate, and all donations are matched 1-for-1 for the first 10,000 donations. So donate now. All right, donate now. Additionally, we have pillars along the way, like streaming for 24 hours straight, shaving my head here live on stream, and shaving my beard, which our goal is not to hit that goal. All right, no one wants to see that. No one wants to see that. So let us continue on our journey here. Now, I didn't see any questions, so I hope y'all are golden on this right now. I hope y'all are golden on this. Let us continue on our journey. So, step 1, let's open up our dungeon crawler. And we have a design doc here. So let's go ahead and check out this design doc. So, here at the bottom of our design doc, we can go ahead and add a couple new lines. And this is where we can keep track of what tables we may or may not want. All right, tables we may not or may not want. So what was our dungeon crawler game? It's been a while. Well, we can figure out a couple ways. The most fun way would be obviously, of course, cding to that folder and then just running it. So let's do Python main. Look at that. Welcome to my dungeon game. Let's go ahead and start the game. Ooh. Killed a goblin. Ooh, we can pick up a dagger. All right, and that's currently in our inventory. Let's go ahead and equip our dagger. We got some more items here. Let's go and pick up another dagger. I don't care about these items, so let's just press enter. Oh, we killed another goblin, and there's more daggers showing up. We already got a dagger, so we don't need them. So we'll just press enter. Look at that. We're almost about to die. We just got more daggers, no health potions, and look at that. We have died. All right. So we're just continuously going through and through the game, getting outputs, going to every new additional level, and just progressing through the levels. We can pick up weapons, and I think there's potions and other various consumables that we can end up grabbing through our journey here. And if we look here, we have our main, which is our main function. This will run when we run this, we're assuming it will run when we run this Python file, which will print out dungeon game, give us our main menu options, display it, and then depending on what we pick on the main menu, it's going to usher us on forward to something else. Either the game loop, when we start the game, it will just print when we want to print the scores, and then it will exit when we want to exit. All right, it will exit when we want to exit. So the game loop looks very interesting because that's the loop of our game. So let's go ahead to that function here and see what's going on in this function. Interesting. So, well, I guess before we go into that, an argument could be made that you could make the main menu a part of the database, right? We're not going to do that, but that is something you could potentially do. All right, that is something you could potentially do. I don't think it's really needed, but you know, these are the questions you should always be asking yourself. Should I put this in the database? Yes or no? If not, we'll move forward. So next, game loop. We're playing the game. We generate a new hero, and we're playing the game. We're playing the game, and we go through. We kill things. Bosses are spawned on every 3rd level. And we can either get the tree boss, the sun boss, the moon boss, or we just normally fight a goblin. And then this is our fighting loop, so just attacking back and forth. We have our looting here. We have the player's inventory here. Interesting. And then displaying the inventory, and yeah. And this is all done in this game loop, while loop, and it looks like there's nothing that gets done or printed outside of it. So that's why we didn't get anything that said, oh, you died, game is over. Because we never added looks like a print statement outside of the while loop. So we could just do that real quick right here. Just print, you died. Just so we know when we died. And let's do a new line at the front, because I don't know if we'll need that or not. So interesting. Interesting. So now, when you go through your stuff here, things may or may not pop out on what potentially could be a part of the database. All right. And it's also optionally on you, on what you want to make a part of the database. All right. So everything here could potentially be a part of the database. It's just all about what you want. For example, our goblin, the goblin stats, the tree bosses, the sun bosses, all the bosses stats, their drop tables. All right. Those potentially could all be a part of the database. All right. What are the pros and cons to this? What are the pros and cons to this? Right now, in the current state of this game, it's 100% offline, which means that people can play it without an internet connection. Maybe that's what you want. Maybe that's what you want for your game. That is 100% a-okay. These are things you got to think about when you're making your applications. It doesn't matter if it's a game or something else. For any of your applications, these are things you need to think about, whether you want them to have the capability of being online only, offline only, or maybe a hybrid, both of them. All right, being able to do both. So why would you want maybe bosses to be online? This is where you would look up on a database what bosses they are, what stats they have, etc., etc. Great question. Have you guys ever played any like MOBAs or trying to think? A lot of these games are doing more of a hybrid approach. I'm trying to think of, or I guess like RuneScape as a old school RuneScape, or new RuneScape, or World of Warcraft, or what's a mostly online only game? Whenever you're playing games like that, most of the information about the game, like stats of things, etc., are on the central server. And what happens is you will query out to the server to gain information. About stats, what's on a player's, what a player maybe is wearing, just any general information. You would get that from the game server. The pro here is that you, the person that made the game, at any time could do balancing on the fly and immediately have it pushed out to everyone. So everyone playing your game will immediately have the latest balances, because all you have to do is change records in the database and bam. Now the sun boss is overpowered. Now it's balanced. Now it's nerfed. Now there's a new boss. Let's call it the mega boss, that you just add a new record into the database and bam, you now have a new boss in your game. It doesn't require any patching, any maintenance or updating from the user's endpoint. They just need to connect, and once they're connected, bam, they already have all the latest and greatest information. This is really cool and a big pro for the databases. And maybe that suits your game or the application that you're trying to make. What a lot of games will do, so these would be more so things like League of Legends, Call of Duty, Apex, etc., etc. They do more of a hybrid approach, all right? More of a hybrid approach, where a lot of this stuff will be included in the patch that you then have to download onto your computer, and then you have to play on that patch. So it keeps track of what patch everyone's on, and you can only play with people on that same patch. And a lot of this information is on your local machine. And they don't really have the ability to quickly toggle or change this stuff for balancing. They have to redistribute out to everyone a new patch for the game, a new update for the game, which is a little cumbersome, right? A little cumbersome. But it's great for them because it keeps their servers lighter, because the servers don't have to maintain or do as much. You don't have to have as a robust database, or you can offload some of the database's work onto your computer, right? Onto the personal computers of everyone playing the game. So there's pros and cons to all of this. And then additionally, there's just completely offline play. So you can just play offline. You don't need to worry about databases. Any questions on that? Alrighty, so let us chug along here. So for our game, the bosses, I think we're going to leave alone. The goblins, I think we can leave maybe alone. There's the player taking damage. There's the looting ability, which is a part of the enemy's drop tables. So everything in the main game here, there's nothing that really stands out right away that we could migrate to a database. Because unlike the word guessing game, we weren't really saving anything to a file to begin with, right? We weren't really saving anything to a file to begin with. So it's not really easy to pick anything else out that's just low-hanging fruit. So again, this would be more of the design aspect for you. So if we look here, we could potentially do stuff or add maybe some score mechanic in here, because we're currently not logging the score or how high someone is getting. So we could easily add a high score table just like we did for our other game and add it in here also. Additionally, we could do it so the drop tables of our guys here are being created from the database. Where's our mobs? So the drop tables here could come from the database. Let's see here. Not only just the drop tables, but maybe the stats. So how what their base defense. Where's this is for mobs. And then for goblin, I guess goblins don't have anything. Here we go. So their health here. So these are the bosses. So their base health. And what else do we got here? Health. How about the attack value? I think that's from how we wrote this game. Let's see here. From the mob. Mob is from fightable. And this has the base defense, the base attack. We could potentially get those from the database also. Not really too big a fan of all of those. So maybe we won't go too database heavy on this. Maybe this will be a hybrid setup. Just like all those bigger games like Call of Duty, etc., etc. Because we already have pretty much all the logic here for the player to run locally. And it wouldn't be that easy of a switch over to get it to read from the database. Not like how it was in the word guessing game. So maybe we just want this to be offline and then just add the high scores that people get, so completely offline. And if they have an internet connection, we want to then update the database with their progress. Or maybe they have an account with our services where they can load up their player information and continue where they left off. We could potentially do something like that also. Lots of different options we have here. I think we're going to go with either the scores or saving a user profile and being able to load up. Interesting. Let's take it one bit at a time. I think the easiest thing would be to do is high scores on how high of a level someone got, and then them being able to enter their name. So this will require us to not just add the SQL code, but also to add some logic to collect their name, right? To collect their name. So we can add it here right after we print the message they died, so they have the option of adding this information and having it sent up. So what can we do here? That's right. We can copy and paste because we're pretty much going to use the high score table just like we did in the word guessing game. Not too much different or new. All right, not too much different or new for this. So let's go ahead and go to our word guessing game here. And this high score logic we can basically copy and paste over here. And it's pretty much going to be very similar to this current state. But we can't just use this because this is the high score table for our word guessing game. So even though these tables are pretty much going to be the same, let's make another one for our dungeon crawler game. Luckily for us, we don't need to make one from scratch. We can easily make one from the startup script here because we have the creating high score table script. So let's actually copy this entire file. And in Dungeon Crawlers, let's go ahead and make a new folder called Startup. And in here, let's go ahead and paste that file. So we basically copied that entire file. And in here, we can just modify it to create that high score table, but we don't want to call it high score because that table is already being used by our word guessing game. So at the end here, maybe we'll just add a DC. So high score DC. YDC, dungeon crawler. All right, just dungeon crawler DC there. So we'll go ahead and add that, and pretty much everything we can keep exactly the same. So we'll just keep this the same, except we need to run this because we want this new table created. All right, so if we go ahead and cd into our startups folder and we do Python creating, there we go, and it says, oh no, something bad happened. Ooh, this is new. We have not gotten this error before. All right, we made this catch-all except for anything else, but we never really had a good way of testing it. But here, right now, we can see a way that we can go about actually testing it. We actually brought it up and we handled it nicely. All right, we handled it nicely. It says multiple primary keys for table high score are not allowed. Interesting. Let's break this down. We had something bad happen. What the bad thing that happened is this error message where it's saying we have multiple primary keys. Remember, your primary keys are going to be that ID key because that's going to be our primary key that gets auto incremented and we're indexing on it by default. All right. And it's for the table high score, and that's not allowed because there's already something apparently on that table high score. Look closely, all right? Because again, when you're first starting out, you may be very, very, very confused and very, very lost. You're gonna look here and be like, what do you mean? This is a brand new table. It's called high score DC. We just made it right now. I've never made this table ever before. Why is it giving me this error? Read the errors closely. Every single word is very important. All right. It's easily confusing sometimes if you just breeze through it. Our table is called high score DC. This is saying table high score. These are not the same tables, which means this SQL statement is not the one that it's having an issue with. It's one of these ones below. And what do you know it? If we look here, we can see that alter table public.highscore is incorrect, right? Is incorrect. We don't want this to be high score. We want this to be high score DC, right? High score DC. So let's rerun this now and see what we get. Everything went well. So it was a super simple error, but again, it can give people a very large, massive headache, right? Half of it is our fault because we already have a high score table and we're kind of working this one in there, all right? So we're not using the best naming conventions off the bat because we're mixing our dungeon crawler database alongside with our word guessing database. We should have these completely different, but they're all meshed in the same place, all right? So the more ideal thing is to have these more separated out, but we're working with what we got, all right? We're working with what we got. So just pay attention to that because it can be unpleasant. If we look at our database viewer here and we go ahead and refresh, we can see that we should have a new table. Refresh. We do not have a new table. Why do you say everything went well? Doesn't look like everything went well to me. So it's saying everything went well, but I don't think everything went well here. High score DC. Let's rerun this again. Everything went well. Refresh. We have a high score table in here. What are these little icons here? No connection to the database. Are we not connected? Let's disconnect from the database. And then let's reconnect to the database. If we reopen this, should reconnect. Interesting, interesting. Why you do this to me? I wonder if this last one had any issue. Let's rerun this script and refresh. Why? The only last thing I can think of is it doesn't like our names here because our constraints name and right here and right here are potentially conflicting with the other one. So let's go ahead and change all these high scores to high score DC. Oh, this is also wrong right here. So let's change that to high score DC. All right. Again, these are going to be issues that you might run into when you're naming things so close to each other. All right. So let's go ahead and rerun this now and see if it will show up. And it does. All right. Now it does show up. And it looks like it's high score DC all lowercase because our table names need to be all lowercase. So technically this should be all lowercase, but it handled it for us. So everything is working now. It was just our naming convention that was the issue. All right. So the error wasn't that great for us. Most likely the error was giving us the duplicate table because it thought still we were doing stuff on the high score table. In reality, we weren't. We were wanting to create this new table. All right. So some of those, you know, really frustrating things for programming that you could come across. So the best thing is just don't have a table name so close, if possible, to something else. And if you do, make sure you change every little thing in here to reflect the new name. So let's continue on. Let's go ahead and do a git commit because we just added this startup folder and this creating high score script. So let's do a git add all. And we should cd out one, git add all, and then git commit. And in here, we want to say that we added a new DB high score creation script. All right. We'll go ahead and push that up. And there we go. We have now added this, and now we have a way of storing the high scores, right? A way of storing the high scores. Now, we do have an issue here because we got to finish up our code in our main. When after we die, we need to collect the user's name. We're already collecting the level, so we don't need to worry about that. But we need to do some importing because we aren't importing in here. If we look at the top, anything that has to do with databases, because this is brand new database integration. So we can always refer, I'm going to close everything else here in the tabs, to our previous older code. Steal from yourself. It's okay. All right. So let's go up here, and we know we need this PsyOps PG. And then also for our high scores, we need this date time stuff. So let's go ahead and grab both of these import statements and copy and paste them over, because we know we're going to have to use these. Additionally, we don't have the DB connect function, so we could copy that over, or since we're just using it as a one-off right now, what I mean by that is we only have one time we're connecting the database, we could just paste it in here like that and have it hard-coded. And looks like we still need a way to get the name, and instead of score, this is going to be level. This is going to be level, which runs into an issue with our startup script that we missed, is we're doing score here while this should be level instead, right? This should be level instead. So let's go ahead and fix that issue. Let's go ahead and delete the old table in here and rerun this. So it has, we need to cd into startup and then Python creating. Score does not exist. This needs to be level. All right, this needs to be level. Rerun that. There we go. Now the table's created with this column called level instead of score. Remember, you have to change this because we are creating a custom index based off of this level column. All right, not just the ID column, but the level column. All right, so that's why we had to change this one. This is the only required field for us to change, which we need to say go look at level instead. This is to make sure the variable name, this thing right here, is called correctly. It's not called underscore score index because it's not for the score, it's for the level. All right, let's go back to our main here. So we're going to insert into high score, not DB, but DC. This is named correctly, right? Yeah, DC. We got name, level, timestamp. So we're going to do the name, the level, and then the timestamp. The last component we're missing is collecting the name. Luckily for us, in our word guessing game, we already have that logic created right here. So we can just go ahead and steal some more code from ourselves. We can go and copy, paste, steal that. Now we have it right here, and we're good to go. This should be pretty much all the alteration we have to do in order to have this fully connected to the database, right? Fully connected to the database. The only potential issue right now is our game was perfectly offline, in a perfect offline setup, so the player never had to connect to the internet. Now, they technically can play the whole game completely offline, but whenever they die, they'll get to this, and if they're not connected to the internet, it's going to be a bad day for them because it's going to error out. It's going to be really sloppy, not good, blah, blah, blah. So we may want to wrap this entire thing in an if statement that will check if they're connected to the internet, then try to reach out to the database and do the score thing. But if they're not connected to the database, maybe instead we just completely skip saving their score, or their scores are saved to a local file that then later on, when they do connect to the internet, will push all of their locally saved scores up to the database. All right. There's a bunch of ways you can go about doing this. All right. So that logic, I think, we'll add in here after we run the game and see if we can update the database by playing through. So let's go ahead and run our game here. So let's do Python main. We'll go ahead and start our game. All right. So we can see we got a dagger. Let's go ahead and equip the dagger. Let's go ahead and go next thing. I don't want to do, ooh, there we go, a potion. Let's grab the potion. Let's go ahead and drink the potion. There we go. We just fought a boss and we got another potion. Oh, another potion. All right, we got a bunch of potions in our inventory. We're at 15 health. I think we're good. We'll go and drink another potion. Oh, could have picked up another potion. Clicked. All right. We can play this game for quite a while. So let's go ahead and die. So I'm going to keep on pressing enter until we die. Look at that. We died. Enter a name to be saved on the high score list. Instead, this should probably say the high score board because it's going to be posted on the database where everyone can potentially see it. The high score board or the high score database. Whatever you want to call it. It's totally up to you. This is your game. And then we'll go ahead and put a name. So we'll say Elijah. And it looks like it worked because we didn't get an error. So the last thing to check is maybe the database. And if we go to, we got to refresh everything. So let's refresh. High score DC. Look at that. Elijah got a high score of reaching level 10. And look at that. Now we have a high score ability in our game being sent to the database, So that's really, really cool. That is really, really cool for us. This opens the possibility for a lot of stuff. Of course, there's like the in-game high scoreboard that you can have, but you're not just limited to that. You can now potentially make this into an API that can now be accessible via a website and other stuff like that. For example, again, this is not just for games. Games are the easiest example that we're all familiar with games to a certain extent. So this isn't just for games. We're just going to be giving a lot of game examples right now. But an example of how this could be potentially useful, whether you've played RuneScape or not, doesn't really matter. But on RuneScape, there's this thing called the Grand Exchange, which allows you to trade. It's basically a marketplace where you can trade items with other players around the world. But they have it set up so it's all interacting via their databases. And these databases are implemented so you can interact with them in the game, so you can do trading in the game. But remember, these are databases. They're just a server. Any code that you write could be potentially messed with or look at the database. So what they did here is they made APIs, all right, APIs where you can interact with the data in the databases. So you could make something like a website, which they have here for looking at things that are being sold, bought, their current price, like how many of each item was sold, etc., the monthly change. All of this is now viewable from the website, which is not possible unless you're using a database, right? Unless you're using a database. So we could do the same thing here because we went over on our earlier days how to make an API. In our API code here, we could easily have it so it connects to the database and then returns, what the current high score is or what the top 10 high scores are. Or we could return the data for what the high scores trend has been over the last month. All right. This could be maybe the growing trend of the highest levels or maybe the average level. There's a lot of things we could potentially do with the data. And because it's being stored on our database, it just opens up the possibility of all the various things we can do in a very powerful, awesome, epic way for us. All right. Any questions on that? Any questions on that? Like I told you guys earlier, you know, we're done with foundations. Now we're just stitching all of this stuff that we learned together and showing kind of how they can all work together and how you can make powerful and more powerful and more powerful things that can potentially revolutionize and change the world and make you a lot of money and make you a lot of money at the same time. All right. And it doesn't really get any more complex per se than this. All right. You got your if statements, your while loops. There's ways you can store your data through a database. We talked about SQL, but there's other types of databases we brought up. They're just storing stuff, kind of like how you can save it to a file. It's just a different way of doing it, right? And you can read from a file. You can read from the database. And when you do that, you can use something like an API to make it available. All right. Again, you got your local libraries where you can then access them via their local APIs, or you have an internet API, all right, a web-based API that you can set up to have it potentially available to everyone around the world. Now you can lock it down so only your services can talk to your web API, but the opportunity is there. Opportunity is there. So I don't see any questions coming in, so please ask questions. So what we're going to do tomorrow is do that example I just showed you of RuneScape, all right? We're going to play our game. We're going to play our game a bunch, all right? So we can generate a bunch of different high scores at different levels, all right? Then we're going to modify our API so it can connect to the database and then display what the current high scores are, maybe so we can also see high scores over time and kind of get some nice graphs going on. Python doesn't really have a way to display this data super nicely via the terminal, right? So we're going to use this time to pivot and transition to HTML, CSS, and JavaScript, all right? HTML, CSS, and JavaScript, so we can kind of see the full stack. So HTML, CSS, they're not actual programming languages, right? They're pretty much just ways they're markup languages. So kind of like these read.md files. This is how to do a big header right here. It's kind of the same way. It's a markup language. So we'll show you guys the basics of how to use it. We're not going to show you how to become a pro at it at any extent. JavaScript we'll hit into very, very lightly. We're not going to make you a pro at JavaScript, just like how we didn't really make you a pro at C, all right? Honestly, C we hit on more than we will on JavaScript, but we're going to give the basics, mostly because JavaScript will allow us to potentially make some nice, pretty visuals, all right? So that will be what we're going to execute on tomorrow and for the rest of the week, because we'll be able to make the APIs tomorrow, and maybe we'll start on HTML, and then we'll spend the rest of the week learning HTML, CSS, and then integrating the JavaScript. Any questions at all before we conclude today's stream? All right, I don't see any questions. If you do have questions, please ask them in the 100 Days of Rootkit chat in the Discord at any time, or you can post it as a comment. I prefer if you go to the Discord, all right? But yeah, that's all I got for you guys for today. So I will see you guys tomorrow on the next one.